New topic, lipids and membranes. And we're going to do some nomenclature on some fatty acids. Okay. We're going to first look at our saturated fatty acids. So no double bonds. I'm going to give you the common names first. Lauric, myristic, palmitic, steric, arachidic. Carbon number, lauric is 12, myristic is 14, palmitic is 16, steric is 18, arachidic is 20. Number of double bonds, these are all 0. Okay, so our shorthand notation for this, is a 12:0. So our shorthand notation for this is 12:0, 12 carbons, 0 double bonds. So these are all pretty easy. Okay. Now, if I have 12 carbons, to shorthand this, I need what, 10 methylene groups? Okay, so that would be lauric acid. Myristic, 14 carbons, palmitic 16, arachidic 20, so you can do the math there, okay? If you have the acid, IC acid suffix, if you lose the hydrogen, dissociates, drop the IC acid and add the ATE, so laurate, myristate, palmitate, okay? IUPAC. This is 12 carbons, dodecanoic acid. Okay. Tetradecanoic acid, hexadecanoic acid, okay, octadecanoic acid, 20 carbons, icosanoic, icos for 20, okay. So again, I'll let you fill in all of that, all right. Unsaturated fatty acids. Okay, this list can be quite extensive. Generally, if you have an unsaturated fatty acid, this double bond, and we show that as a delta, so delta means double bond. So usually it's at the 9 position. So you got a double bond at the 9 position, and these are cis in their configuration. So you have cis alkenes only. All right. So if we have a double bond, we're going to normally put it at the 9 position. There's of course exceptions, and it will be cis. Okay. All right, so we'll start with 16 carbons. So palmitoleic is a 16-1. Oleic is an 18-1. Linoleic is an 18-2. Linolenic, notice the extra letter, linoleic and linolenic, has an 18-3. And there are 2 forms of linolenic. There is the alpha form and the gamma form. Okay. And they are both 18-3. The double bonds are in different positions. Okay. Now, with the double bond, I'm going to have to draw this out fully. So there's 2, 4, 6, 8. 9 has the double bond and the cis. So 9, 10, 11, 12, 13, 14, 15, 16. So count your carbons because I'm going to. 2, 4, 6, 8, 9, 10, 11, 12, 14, 16. Whoops, too many carbons. I got ahead of myself. Okay, it's supposed to be 16 carbons total. I'm doing the structure for the next one, okay? All right, so, excuse me. 16, again, let me count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so let me do OLAC. I would just add 2 more carbons, right? You get the idea. 2, 4, 6, 8, 9, 10, 11, 12, 14, 16, 18. So again, count 2, 4, 6, 8, 9, 10, 11, 12, 14, 16, 18. Again, the double bond is at the 9 position. Okay, so that's your OLAC. Linoleic, it's an 18-2. If you have 2 double bonds, they are usually separated by a saturated carbon. They are not in conjugation. So let me do this one. 2, 4, 6, 8. 2, 4, 6, 8. Here's 9, 10, 11, 12, 13, 14, 16, 18. Count your carbons. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Notice that this is not conjugated. That this is an sp3 hybridized carbon. And notice that it is allylic. It is adjacent to a double bond. In fact, it's adjacent to 2 double bonds. Okay, so notice again that those positions are allylic, just like positions 8 and 11 are allylic up here. Okay, adjacent to the double bond. So if you have a polyunsaturated, you're going to have 2 or more double bonds, and they are separated again by a sp3 hybridized carbon. Now, I'm going to go to the next page to give you the IUPAC nomenclature of these and draw the next 2 structures. Okay, so again, I'll rewrite this. Palmitoleic. So palmitoleic is a 16-1, and by IUPAC nomenclature, this is a delta 9 hexadecaenoic acid. Hexadecaenoic acid. Okay. Oleic is your 18-1. This would be delta 9 octadecaenoic acid. Okay, so linoleic is an 18-2, so you have delta 9, delta 12, octa, deca, dienoic acid. I can't make this stuff up, folks. Your alpha-linolenic is an 18-3, and you have delta 9, delta 12, delta 15, octa, deca, trienoic acid. Okay, and your gamma linolenic is an 18-3, but the double bonds are in different places. You've got a delta 6, a delta 9, and a delta 12. So the double bonds, again, 6, 9, and 12, octadeca trienoic acid. Okay, so I did the structure of these on the previous page. Let me do the structure of these 2. So 2, 4, 6, 8. So 2, 4, 6, 8. Here's your 9, 12. So 15, 16, 17, 18. So again, count your atoms, 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons. And again, this is at 9, 12, and 15. Your gamma linolenic, so at the number 6 position, you have your double bond. So 2, 4, 6, here's your double bond. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? So here, count your carbons. 2, 4, 6, 7, 8, 9, 10, 11, 12. So 6, 9, and 12. 13, 14, 15, 16, 17, 18. 18 carbons. Okay. Now, if we are numbering from the end, these are referred to as omega. And so this is an example of an omega-6 fatty acid. If I count from the end, okay, the omega carbon is the last carbon. 1, 2, 3, 4, 5, 6. I'm 6 carbons from the end. This is an omega-3 fatty acid. Okay, 1, 2, 3. And you hear a lot about omega-3 fatty acids being healthy, okay, but you very rarely hear anything about omega-6s. In fact, it's the omega-6 fatty acids that are essential fatty acids. We cannot make these. We must get these in your diet. So a total fat-free diet is really not that wise. So again, your linoleic and your gamma linolenic, these are your essential fatty acids. So these are your essential fatty acids, and these are your omega-6 fatty acids. Again, if you look in a textbook and look at nomenclature, you'll find a lot more stuff on your unsaturated fatty acids, things like EPA, icosapentaenoic acid is another common one that gets a lot of attention in the media.